Okay, so welcome back from our spring break. Hopefully, everybody had a nice and relaxing spring break. Um, but we are going to get right back into our factoring that we were working with. If you can remember, the last video we were working with, we were factoring things that were in the form x squared plus bx plus c, where my coefficient for my x squared was always a 1. Well, today, now what we're going to be doing is we're going to be talking about what happens when this coefficient is not 1 anymore. Now, we're going to talk about how to factor ax squared plus bx plus c. It's a little bit different than what we were doing before, but in a lot of ways, it's also the same. So let's just take an example here. Let's say we wanted to factor out 2x squared plus 5x plus 3. Okay? So normally, when we didn't have an a, our first thought was we wanted to find two numbers that multiplied to get 3. Well, now it's going to be a little different. Now we're not looking for two numbers that multiply to get 3. We're going to look for two numbers that multiply to get 3 times 2. So now we're going to look at a and c. So now we're going to look for my factor pairs of AC. So in this case, we're going to look for factor pairs of 2 times 3 or 6. So we're going to be looking for any two numbers that multiply to give us 6. Now again, that shouldn't be too difficult. We have 1 and 6. We obviously have 2 and 3. We could also work with the negatives, meaning -1 and -6, and -2 and -3. But I know that that's not going to work because the second part of this is not only am I going to look for factor pairs of AC, they still have to add to B. They still have to add to this middle number here. So we're going to look for two numbers that multiply to get AC, but also add to become B. So out of these pairs, I'm looking for which one adds to equal 5. Well, 1 plus 6 does not equal 5. That's going to equal 7. 2 plus 3, that equals 5. So this is going to be the pair that we want. So this first part of it's very similar to what we were doing before. This is where it changes a little. So now, once we have our factor pair, what we're actually going to do is we're going to rewrite my trinomial into a 4-termed polynomial by taking this middle term here and rewriting it using these two terms here. So what I'm going to do is instead of having a 5x, I'm going to rewrite 5x as 2x plus 3x. I'm going to take the two numbers that we got here, and I'm just going to use those two to rewrite the middle term. So the 5x is now going to become 2x plus 3x. And 2x plus 3x does equal 5x, so we're not changing the value of it, we're just rewriting it. The first and the last term, those are going to stay the same. So this is going to stay as 2x squared plus, and this is going to stay as plus 3. But now that I've rewritten this, now I have a 4-termed polynomial. And if we think all the way back to when we were working with our 4-termed polynomials, in order to factor a 4-term polynomial, we need to factor this by grouping. So I'm going to group my first two terms together. I'm going to group my second two terms together. And I'm going to say, out of my first two terms, what is the GCF of 2x squared and 2x? Well, the GCF of 2x squared and 2x, that's going to be 2x. So what's left? I take 2x squared, divide it by 2x. That's going to give me x. I take 2x, divide it by 2x. That's going to give me 1. Then I do the same thing with the second parenthesis. What is the GCF of 3x and 3? Well, the GCF of 3x and 3 is 3. Take the 3x, divide it by 3. What's left? That's going to be x. Take 3 divided by 3. What's left? That's 1. And again, if we remember grouping, once we get to this point, we want to make sure that my two parentheses are identical. In this case, they are. So what I do is I take my two GCFs, the 2x and the 3. Those go in their own parenthesis. So it becomes 2x plus 3, because this is a positive 3. And then in the other parenthesis, we use the twin of x plus 1. This would be my final answer. This would be the fully factored form. And again, I can always check this. If I needed to, I can just take this and I can double distribute. I can take the 2x, distribute it to both. I can take the 3, distribute it to both, and see if I get 2x squared plus 5x plus 3. And in this case, I would. So in a lot of ways, when we're factoring with a coefficient that is a, or that is not 1, it's very similar. The only real difference is, instead of looking for factors of c, we now have to look for factor pairs of ac. So we're looking for a times c. And then, instead of just putting it into the two parentheses, we have to take the middle term, split it up into the two numbers that we get, and then we have to factor by grouping. So let's try another one of these together here. So let's say I wanted to factor the trinomial 7x squared plus 29x plus 4. The first thing I have to notice is that, again, this is a trinomial, but my a is not 1. So I can't do it in the normal way of just find two numbers that multiply to get c and add to get b. I have to find two numbers that multiply to get ac. So the first thing I want to figure out is, well, what is ac? Well, in this case, a times c, 7 times 4, is 28. So I'm looking for factor pairs of 28. Well, my factor pairs of 28, that's going to be 1 and 28. I'm going to have 2 and 14. I'm going to have 4 and 7. And I'm pretty sure that that's about it. So now I'm going to use these to say which pair of these is going to add to be 29. We want them to add up to equal 29. Well, 1 and 28, there it is. That's going to be the one that adds to be 29. So this is the pair that I'm going to want to work with. I want to work with the pair 1 and 28. So I'm going to take my middle term and I'm going to split it up into 1x, because of the 1, plus 28x. The first term just comes down, so 7x squared. The last term just comes down, plus 4. And now I have a 4-termed polynomial. 7x squared plus 1x plus 28x plus 4. Now with my 4-termed polynomial, I'm going to factor by grouping. Group the first two terms together, group the second two terms together. What is the GCF of 7x squared and 1x? That's just x. So when I take the 7x squared and divide it by x, I'm going to get 7x. When I take 1x and divide it by x, I'm going to get 1. I do the same thing for the second one. What is the GCF between 28x and 4? That's going to be 4. 28x divided by 4x, that's going to give me 7x. 4 divided by 4, that's going to give me 1. Now I look at my two terms here. I see that 7x plus 1 and 7x plus 1 are the same. So I take my GCFs, the x and the 4. They're going to go in one parenthesis, so it's going to be x plus 4, because the 4 is positive. And then the twins, 7x plus 1 will go in the other parenthesis. And this would be the factored version of 7x squared plus 29x plus 4. It would be x plus 4, 7x plus 1. Let's try one more. Let's look at one more here. Let's say that I had 3x squared plus 15x plus 18. So for this one, your first thought would be, oh, well, a is not 1. So I'm going to want to take AC and multiply it together and look to do the same thing that I had just done. But in this trinomial, hopefully some of you have recognized, there's a GCF between all three terms. Remember back when we talked about GCF, we said no matter what, when you are factoring, you should always look to see, is there a GCF between all of my terms? And in this case, I do. I have a GCF. The GCF of 3x squared, 15x, and 18 is 3. I can factor out a 3 first. And when I factor out a 3, I take each term, I divide it by 3, and I say, okay, 3x squared divided by 3, that's going to give me x squared. 15x divided by 3, that's going to give me 5x. 18 divided by 3, that's going to give me 6. So my first step is to look to see, well, maybe I have a GCF that I can pull out, because now if I look inside the parentheses at what's left, now this is not a trinomial with a coefficient that's not 1. This is a trinomial with a coefficient of 1. So I would do this regularly, like we were doing before spring break. I would say, okay, what are the factor pairs of 6? And the factor pairs of 6 are going to be 1 and 6, 2 and 3. Which ones add up to be 5? That's going to be 2 and 3. So because this is a trinomial with a coefficient of 1, I can do this the easy way. Just put the two parentheses, and it'll be x plus 2 because of the positive 2 here. And then the x plus 3 because of the positive 3 here. But I can't forget the 3 that I factored out in the beginning. So this would actually be my final answer. It would be 3 times x plus 2 times x plus 3. So you really have to be careful with these. When you see a coefficient in front of x squared, look to see, maybe I can take a GCF out first. If that's the case, it makes it so much easier. I don't have to worry about splitting up the middle term and factoring by grouping. If that's the case. Obviously, like the previous one that we just did over here, that's not the case. 7, 29, and 4, they don't have a GCF that I can just pull out. So unfortunately, there will be some where you can't take a GCF out and you have to do it by splitting the middle term up, factoring by grouping, and then getting our answer. But if you have one where you can take a GCF out, try to remember to do that. Now, if you don't remember to do that, you'll get an answer. It won't be fully correct. Let's see what happens when we do that. Let's say we didn't realize that we had a GCF of 3 here. And we went through this problem saying, okay, what is AC? Well, AC in this case is going to be 18 times 3, which is 54. So here I'm going to have AC is equal to 54. And now I have to look for my factor pairs that add up to equal, I'm going to have to look for factor pairs of 54 first. And then I have to find what factor pairs add up to be 15. So just to go through this a little quicker, the multiples that add up to be 54 and add to be 15, that would be 9 and 6. 9 times 6 is 54, and 9 plus 6 does equal 15. So I would split the 15x up into a 9x and a 6x. I would bring the 3x squared down, I would bring the 18 down, and then I would have to factor this by grouping. And I would say, what's the GCF of 3x squared plus 9? Well, the GCF of 3x squared plus 9, that's going to be 3x. That's going to leave me with an x plus 3. What's the GCF of 6x plus 18? That's going to be 6. And that's going to leave me with x plus 3. Now, I do see that I'm getting a twin here. So I'm going to take my two GCFs, the 3x and the 6, and I'm going to write that in one parenthesis, 3x plus 6. And then in the other parenthesis, I'm going to write x plus 3. But then, at the end here, you have to realize if I look at this parenthesis, 3x plus 6, that actually has another GCF to it. And that GCF is 3. So I have to take another GCF out. And then I'm left with x plus 2 there and x plus 3. And now look at that. I end up with the exact same answer. But look at how much more work this was. Okay, so if you do have a GCF, you always want to take that GCF out in the beginning. It will make the problem a lot easier. So here are two more problems. I'd like you to try these on your own. Hopefully you can get them. Again, just as a hint, always look for the GCF first. If there is a GCF that you can take out of all three terms, take that out first. But again, pause it. I'll give you about 5 minutes. Try and solve these problems on your own. All right, so hopefully you got these answers. So for the first one, there was no GCF between 5, 13, and 6, so we just had to do this the normal way. Look for the AC, which in this case is 5 times 6, which is 30. So we're looking for all the factor pairs of 30, which you have 1 and 30, 2 and 15, 3 and 10, 5 and 6, and we want them to add to equal 13. So the only one that adds to equal 13 is the 3 and the 10. So I take 13x, split it up into 3x plus 10x. Then we take the 5x squared and the 6, bring it down. We have a 4-term polynomial, which we want to factor by grouping. In the first grouping, the GCF of this is x. In the second grouping, the GCF of this is 2. When I take the x out of here, I get 5x plus 3. When I take the 2 out of this, I get 5x plus 3. We do see a twin. I take my GCFs, put them in a single parenthesis, so x plus 2. I take my twin, put it in the other parenthesis, 5x plus 3. That would be my final answer. Now for the second one here, we realize that in all three terms, we have a GCF of 2. Well, if we have a GCF of 2 in all three terms, take it out first. So I take the 2 out first, and I'm left with, when I divide all of these by 2, I'm left with 3x squared plus 11x minus 4. Now, unlike the other one where we had a coefficient of 1 here, we don't have a coefficient of 1 here. So I actually still have to do this by splitting it up and factoring by grouping. But I kind of only work with this. This 2 will follow us through the entire problem, but we don't really work with it anymore. Once we've taken a GCF out, it kind of just follows us, kind of like an annoying little brother or sister. Okay, it kind of just follows us into the answer. We don't worry about it anymore. It's there. We know it's going to be part of the answer. We just bring it along with us. So we're really going to focus on what's inside the parentheses, the 3x squared plus 11x minus 4. Again, I'm going to look at AC, which in this case is 3 times negative 4, which will be negative 12. So I'm looking for all the factor pairs of negative 12. So in order to get negative, one of the two numbers has to be negative. So it's either going to be 1 and negative 12, 2 and negative 6, 3 and negative 4, or the opposites, negative 1 and 12, negative 2 and 6, or negative 3 and 4. But I want it to add to be 11. So when I add them all up, here I get negative 11. Here I get positive 11. So I'm going to take the negative 1 and 12. I'm going to split up the plus 11x into negative 1x and positive 12x. I now have a 4-termed polynomial. Remember, we don't really worry about this GCF that we took out in the beginning. it's just going to come with us into the answer. I'm more focused on what's inside here. I take this 4-term polynomial and I factor by grouping. In the first grouping, I only have an x as a GCF, so that comes out front. In the second grouping, I have a 4 as a GCF. That comes out front. What's left here, when I divide by x, would be 3x minus 1. What's left here, when I divide everything by 4, will be 3x minus 1. I do see twins, so I take my two GCFs. They go in one parenthesis, the x plus 4. The other parenthesis is the twin, the 3x minus 1. And then I can't forget that 2 that I had taken out in the beginning. So it's 2 times x plus 4 times 3x minus 1. Okay, so let's do another one together. Let's say I had the trinomial 3x squared minus 17x plus 20. So very similar to what we had before. The only difference are my signs. But we know how to deal with the signs because we did that when we were talking about a trinomial that had a coefficient of 1. It's really no different. So I'm going to take this, and again, I realize that all 3 of my terms do not have a GCF, so I can't take that out. But I do see that we have an A, so I'm going to look at the factor pairs of AC, and AC in this case is 60. So I've got to worry about the factor pairs of 60. All right, so this may take a little while in writing all of them, but remember, you don't have to write them all. Once you find the factor pair that works, you can use that one. You don't have to write all of them. But let's try and write as many out as we possibly can. So we want a factor pair of 60. So we have 1 and 60. We have 2 and 30. We have 3 and 20. We have 4 and 15. We have 5 and 12. We have 6 and 10. And I think that would be everything. But now, if we realize something, I want them to equal, when I add, they have to equal negative 17. So I want them to add up to be negative 17. Now, if I add these together, none of these are going to give me a negative number, right? Well, that's because another way to get positive 60 is to make both of them negative. So I could have negative 1 and negative 60, negative 2 and negative 30, negative 3 and negative 20, negative 4 and negative 15, negative 5 and negative 12, negative 6 and negative 10. So you have to remember to look at the signs, right? If this one is negative and this one is positive, you obviously know that both of your numbers are going to be negative here. So now I'm looking for which pair adds up to equal negative 17. That's going to be the negative 5 and negative 12. That's going to equal, when added, to be negative 17. So those are the two that I'm going to work with. So I'm going to take those two, and I'm going to split up the middle term of negative 17x. I'm going to split it up to be negative 5x and negative 12x. I'm going to bring down the plus 20. I'm going to bring down the 3x squared. So I have 3x squared minus 5x minus 12x plus 20. So again, I'm going to take this. I'm going to factor by grouping. Group the first two terms. Group the second two terms. In the first group, I look and I say, okay, the only GCF here is x. What's left is going to be 3x minus 5. Now in the second grouping, remember what I said. If you have the first coefficient being negative, you should probably factor out a negative number. So because this is negative 12, I'm going to factor out the negative GCF of whatever 12 and 20 is. Well, if we think the GCF of 12 and 20 is going to be 4. So I'm going to factor out a negative 4. So this is going to actually become, when I factor out a negative 4, I'm going to take this, divide it by negative 4. I'm going to get negative 12x divided by negative 4. That's going to give me a positive 3x. And then 20 divided by negative 4, that's going to give me a negative 5. And now if we look, I do have twins. So I'm going to take my two coefficients, put them in 1. So it's going to be x minus 4 because the 4 is negative. And in the other parenthesis, it's going to be 3x minus 5. And that's going to be my final answer. Okay, so again, I've got two problems here up on the screen. I'd like you to pause the video, take about 5 to 10 minutes, and try and factor these two problems on your own. Okay, so hopefully we got these two answers here of 2n plus 1, n minus 1, and 5 times y minus 2 times 2y minus 3. The first one was pretty straightforward. Look for AC. AC is going to be negative 2. So we want the factor pairs of negative 2, negative 1 and 2, negative 2 and 1, not too many. We want it to add to equal negative 1. The only one that adds to equal negative 1 is the second pair. So I rewrite this middle term with a negative 2n plus a 1n. I know it's a little hard to see there. Then I take my 4-term polynomial, split it up, factor it by grouping. Take the first two, the GCF of this is going to be 2n. When I take the 2n out or divide each term by 2n, the first one gives me n, the second one gives me 1. That's where I get this from. Here, I don't really have a GCF, so if you see that there's no real GCF, you can always factor out a 1 here, or at least put a 1 here, just so that you know what's coming out. So when I factor out a 1, obviously nothing will change inside. I'll still have that 1n minus 1, or just n minus 1. So I have the 2n and the 1 as my GCFs. I see a pair here for the n minus 1, and that's the second factor. Now for this one, we had to realize that with the 3 terms, we had a GCF of 5. That has to come out first. So the GCF of 5 would come out front. I would take every term divided by 5. 10y squared divided by 5 is 2y. Negative 35y divided by 5 is negative 7y. And plus 30 divided by 5 is plus 6. So like I said, once you have a GCF out front, don't worry about it throughout the rest of the problem. Just make sure you don't forget to bring it back down at the end of your answer. It should go out front of your final answer. So that's why this 5 is out front here. But then I just work with what's inside. And I say, okay, 2y squared minus 7y plus 6. I see that it has an a that's not 1, so I look at AC. AC is 12. The factor pairs of 12 are either 1 and 12, 2 and 6, 3 and 4, but I realize they have to add to equal negative 7. So that means I'm not only going to work with the positives, I'm going to definitely want to work where both of them are negative. So it's got to be negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. When added together, the only one that equals negative 7 is the negative 3 and negative 4. So I take the negative 7y, split it up into negative 3y and negative 4y. I now take my new 4-term polynomial, factor by grouping. The only GCF of the first pair is y, so I take out the y. I'm left with 2y minus 3. For the second pair, I see that my first term is negative, so I'm going to factor out a negative GCF. And the GCF between 4 and 6 is 2, so I'm going to factor out a negative 2, which will make the first term a positive 2y, and the second term a negative 3. Caught a mistake that I made there, so that should actually say negative 3 there. There we go. But if we see that these are now a pair or a twin, we see the 2y minus 3 and the 2y minus 3. I'm going to take my GCFs here of y and negative 2. That's going to go in the first parenthesis, y minus 2. I take the twins, 2y minus 3, and I make sure I don't forget about the 5 at the end here. So my final answer would be 5 times y minus 2 times 2y minus 3. All right, let's try one more for this video. So let's say that we have 4x squared minus 3x plus 5. Okay, so right off the bat we realize there's no GCF here. Can't do anything with that. So I see that my A is not 1, so I'm going to look at my AC. My AC, 4 times 5, that's going to give me 20. So I'm going to look at all of my factor pairs of 20. So I've got 1 and 20, 2 and 10, I've got 4 and 5, and that's about it. But I do recognize that my middle term is negative, meaning I want them to add to be negative 3. So I should probably work with the negatives as well, meaning negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5. Okay, well now if I'm looking to add here, this will give me 21, this will give me 12, this will give me 9. This is going to give me negative 21, this is going to give me negative 12, and this is going to give me negative 9. So I end up where I don't have any of my factor pairs adding to be my middle term. Well, if that happens, just like with my other trinomials, when we find a situation like this where we can't find a factor pair that adds to be the middle term, this is what we call a prime factorization, or a prime polynomial. So we would just write prime, and that would be the answer. Okay? So again, if you do the steps, you look at AC, you find all your factor pairs of AC, and none of the factor pairs add up to equal that, then we would call it prime. But make sure you have all the factor pairs and that you didn't miss one, because that's unfortunately the biggest mistake people will make. They'll miss a factor pair. And of course, it's the one factor pair that would have worked. So always check to make sure you have every factor pair that multiplies to get your AC.